everyone, I'm Kat, and right now I'm going to go over the discussion problem, which is the minimum cost to reach the top of a staircase. So here we have a set of costs here, and at each step we have a cost. And what we want to do is find out what is the minimum cost to get to the top of the staircase, which is basically right here, which is the length of the cost array. Okay, so the first question is explain what the brute force solution is. And the brute force solution, well, let's backtrack for a second. You have a couple of choices. At each step, you have the choice to either go one step or two steps. So if you're here, you have the choice of going here or over here. And it's the same for each point of the steps here. Now, this applies to the beginning as well, too. So you have the choice to start at either 10 or you have the choice to start at 15. So really what you're doing is you're starting right here where I is -1. So the cost of this is 0, and the cost of being at this last or the top of the staircase is 0. And what you're trying to do is find out how to get from here to here with the minimum cost. So the brute force solution is basically to find out every single combination. So, okay, what is the cost of going here, and then here, and then here, and then here? Okay, add that up, and then compare that to the cost of going here, and then maybe here, and then here, and then add that up and compare that to the cost of maybe here, and then here, and here, or then maybe here, and here, add and compare, right? So you're going through every single possible combination. Now, when you're going through every single possible combination, that's also called the power set, and that is an exponential amount of possibilities. So 2n. So we already know that the brute force of going through every single possibility is crazy because at each one you have a set, or at each step you have two choices. Am I going to go one step or am I going to go two steps? So we have basically the cost of this is 2n. It might be more because we have this step and this step here, but basically we have an exponential cost, which is why we don't want to do the brute force. But to see how we do the brute force, we can look at the recurrence relation. So basically at any point here, the cost is whatever the cost of this step is, plus whatever the cost of the previous step is, if you the minimum cost of this or that, right? So the cost of I step is going to be wherever you're at plus the minimum of either taking one step back or two steps here. Basically, it's like wherever you are to get here, it's this plus the optimal cost of going through this, right? And because the cost of I depends on whatever the cost of the previous steps were, we know that these are subproblems, right? And because you're trying to find the minimum, this is actually the perfect case for dynamic programming, which we will talk about later. Right now we'll pretend that we don't know that, and we'll just focus on the recurrence solution. Okay, so what is the recurrence solution? Or yeah, the recurrence relation, excuse me. So basically the cost of I is 0 if you're less than 0. So if you're over here, it's going to be 0. So if I is less than 0, and if you are here, if you're at the top of the staircase, the cost is 0 plus the minimum of the cost of I -1, so if you went from 20, or the cost of I -2, if you started from 15. And so that is if I is greater than or equal to, I guess, n meaning the length of the array. And, making this a little bit further here, it's if you're in between, so if you're somewhere in here, the cost is cost of I wherever you're at. So if you're at 20, it's 20 plus the minimum of the cost of I minus 1 and the cost of I minus 2. And so that's if you're greater than or equal to 0, but also less than n. So that's our recurrence relation. And so let's go ahead and pseudocode this. So to pseudocode this, I'm going to have min cost, and we're going to have our costs here. And what I'm going to do, because we want to get to the top here, I'm going to go ahead and append, a 0 to this list. And I'm going to go ahead and just say that we're starting at here. So we're going to work our way backwards. So I'm going to say the index I equals the length of costs, right? Because this is the length, it's outside of bounds, so it's here. And we're also going to append cost.append another, or we're going to append a 0 here. So what we're going to do is we're going to actually include this as part of the costs. Okay, cool. And I'm also going to call a helper function, a recursive helper. I'm going to call it min cost helper. And we're going to do costs and the index. Okay, cool. So, and then what we're going to do here is we're going to return MCH of costs and the index, which is I. Okay, cool. So let's just follow our recurrence relation. So if I is less than 0, then it's 0. So if I is less than 0, then just return 0. But if not, then we return what the costs is. So we're going to say costs of, I'm going to say I, it's index, it's the same thing. Whatever the cost is, plus the minimum of the MCH of I minus 1 and MCH of I minus 2. So for each one, it's going to be either less than 0, which is 0, or it's going to be the cost of where it's at plus the minimum of going back 1 step or going back 2 steps. And that takes care of this because the cost of here is 0. So it's basically, boop, boop, it's basically the cost of I plus the minimum of 1 step back or 2 steps back. Okay, cool. All right, so let's go ahead and see why this doesn't work out. So I'm actually going to clear this. I actually did this ahead of time. So let's start with our MCH, and we'll see why this doesn't work out. So if we have MCH, and we have our costs, and our index starts off at 3, right? Because 0, 1, 2, 3. That's where our I is right now. Well, okay, the cost of what this is, this depends on the MCH of I minus 1 and I minus 2. Okay, so let's do MCH of I minus 1, so 3 minus 1 is 2. And it also depends on the MCH of 3 minus 2, which is 1. I'm actually going to move this a little bit so that I have more room. Okay, so the MCH of 2 depends on the MCH of 1 and MCH of 0. So when you're here, this cost depends on this or that, whatever the minimum is. Okay, and likewise, we just keep going down the tree. This depends on MCH of 0 and the MCH of -1. This depends on the MCH of -1 and MCH of -2. We're going in the negative because 0, there's actually a cost to be at the 0th step here. So it depends on this, and that's all just 0. So that's a base case there. Okay, likewise, this depends on MCH of -1 and MCH of -2. this depends on MCH of 0 and MCH of -1, and so on, so on, so on, so on. Okay, cool. So as you can see, why this doesn't work out is because we are solving the same problems over and over. MCH of 1 is right here. It's also right here. You can see that 0 is right here. It's right there. It's right there. And we're resolving the problem over and over and over. So like I said, the complexity here is going to be, I'm going to say I'm going to say 2 of n. It might be more, but around 2 of n. Okay, so what we're going to do is actually use dynamic programming, because what we've learned is that it is great for if you have subproblems that are repeated, or and minimizing or maximizing a problem, getting the optimal substructure. Okay, we're running out of timer. Ugh. Okay, so how I'm going to change this is, instead of going through each one, we're actually going to memoize this, right? So we're going to have a memo here, which is, we're going to have a cost memo, and that is going to be -2, and that's going to be 0. -1 is 0. And we're going to keep that the same, and instead of this, we're going to say, if the index is in cost memo, return cost memo index. But if not, then the cost memo equals, or cost memo, whatever the index is, equals the cost plus the minimum of that, and then return the cost memo index. This is basically the dynamic programming solution. It's the same thing, except we have a memo now. So what does that look like pictorially? So you see how we have these problems here? Instead of solving it at each step, what we're going to do is we're going to go to the memo. So right here we have, we're going to go down the tree, and we know that anything less than that is 0. So we're going to put 0 and 0. So the cost of this is the minimum of 0 and, or sorry, 10, and the minimum of that, and they're both 0, so it doesn't really matter. So it's 10. Okay, MCH of -1, we go here. Oh, so we know that the cost of 0 is 10. MCH over here, we already know that it's -1, so we just compare it. Okay, cool. So it's MCH of 1 plus the minimum of that, and that's 15 plus the minimum of that, which is 0. So this is going to be 15. And we go on and on and on back up here. I've already done this before, so I can just tell you. It ends up being MCH1 here is 15 plus, I don't know, some ungodly number like 25. And the minimum of 3 is 0. So it's 0 plus 15, which is 15, which is our answer. And that is it.